Hello, and thank you for joining the session today. For those who don't know me, my name is Helene Degeling, and I'm the Director of Minerals Geoscience at the Geological Survey of Queensland in Australia. I've really enjoyed the talks from other jurisdictions around the world. This has been a fabulous forum over the last few weeks. I want to thank the organisers of this wonderful event for allowing me to present, as Queensland is one of only 2 local jurisdictions to be represented. Along with Quebec, all of the others are at a national level. I believe this gives us a unique perspective and allows our much closer relationship with the resources industry to come to the fore. Today, I'd like to take you through an overview of the work that we're doing on critical minerals and why that warrants presentation on a global stage. But first, a little scene setting to bring you up to speed on where Queensland is, in case you didn't know, and where our strengths lie. I'll give this little video a chance to play so you can get your bearings as we head over North and South America, across the Pacific towards Australia. Queensland is one of 6 states and 2 territories in Australia. It's a place of nice beaches, coral reefs, rainforest, desert interior, and not too many people. It also has abundant mineral wealth and some very cool rocks. You can see here that it occupies the northeast corner of Australia, with the capital of Queensland being Brisbane, down here. Some of the locations that I will talk about occur here in the northwest of Queensland, in the Mount Isa region. This area is mostly known for its base metal endowment, including copper, lead, zinc, as well as silver, and also significant vanadium, cobalt, and rare earths. I will also discuss some of the work being done in the northeast of Queensland, inland from Townsville and Cairns, for those who might have visited the Great Barrier Reef, which is here. This inland region has a long history of tin and tungsten production, along with some really high-grade indium. Now, as with most surveys around the world, the Geological Survey of Queensland's role is traditionally one of data custodian and a provider of pre-competitive data. We do this with the goal of supporting industry to make new discoveries in Queensland. Exploration success is our reason for being, and we do this in a number of ways. As custodians of the state's geoscientific data, so that what's been done before is available to inform future success. As providers of pre-competitive data, geophysical surveys, geological mapping, geochemistry. By conducting mineral systems studies, it's much easier to find new big things when you understand where they might form and what the smoke for those systems looks like. And by supporting innovative greenfields exploration through our grant scheme, the Collaborative Exploration Initiative. In a nutshell, we do the jobs that will help industry but are too big, too hard, and too expensive for any one company to undertake. A little more on the scene setting before we get into the science. This image shows Queensland's mineral endowment, firstly with a focus on the northwest of the state. We have copper, of course, in the Mount Isa Cloncurry region, also lead and zinc. We also have a world-class vanadium field near Julia Creek. We have some of the highest grade graphite in the world, not to mention cobalt, these blue dots associated with all that copper. And we have plenty of silver. We also have abundant rare earths and uranium. In the northeast, we lead the way with bauxite. As I mentioned earlier, we have a tin and tungsten mineral field with a long history in the Herberton region, also associated with indium. There's more cobalt, this time associated with lateritic ultramafics, along with nickel and scandium. In short, there's a lot to love about the rocks in Queensland. So now onto the topic that brings us all together. In Queensland, critical metals are more often called new economy minerals. We believe that term more accurately represents the global shifts behind the rise of many of the commodities we are discussing in this forum. That is, a shift away from coal-based power and towards a future of electrification and power storage. A number of initiatives have evolved around the world to meet that consumer, shareholder, and community concern. These include, but are certainly not limited to, the Responsible Minerals Initiative, the Global Battery Alliance, the European Battery Alliance, and many, many more. In the last few years, Australia has pushed for global recognition as a secure and ethical supplier of critical minerals, a topic that I am sure Carol Charnotta from Geoscience Australia will cover in his talk. In November 2019, the Australian Prime Minister, Scott Morrison, signed a deal with the US President for supply of Australian rare earths and other commodities to the US. That agreement also includes a formal research relationship between the geoscience agencies Geoscience Australia and the US Geological Survey. It then expanded to include the Geological Survey of Canada, and as you know, this forum is just one product of that agreement. In 2020, another agreement was reached between the Australian and Indian governments. In this case, cobalt was singled out as being crucial, as were lithium and rare earths. Much of the resources discussion in political circles currently focuses on resources security and criticality. This issue really goes beyond markets and metal prices. It becomes a political issue that demands government response. The Queensland Government's response, amongst others, has been to deliver the New Economy Minerals Initiative. This initiative includes 13 million Australian dollars over 5 years, from 2019 to 2024. Another 10 million was added in June last year to boost the Collaborative Exploration Initiative, Queensland's industry grant scheme, as an industry support measure in response to COVID. The funding is broken into two main streams. The first, Hidden Value, aims to expand on what we already know and maximise what we already have. It will include activities such as the reanalysis of existing core, much of which was only ever assayed for a limited suite of elements, and certainly not things such as the rare earths. We will apply the same principle to our old and existing mine sites, examining the concept of secondary prospectivity for critical minerals in mine tailings and waste stockpiles. We are also doing a lot of work on deposit characterisation, taking a representative set of drill core from significant deposits around the state and undertaking complete characterisation of those samples, including the deposit footprints, to develop a fully comprehensive data set on the state's known new economy mineralisation. The second stream of funding is focused more on supporting exploration for new mineralisation through pre-competitive data acquisition and research. One of the points of distinction between this and other more traditional funding packages managed by the GSQ is the inclusion of a dedicated research block to examine the processing and extraction of critical minerals, particularly rare earths. This is an area of significant cost and uncertainty, which I believe strongly and adversely affects industry's appetite to explore for these minerals. If we can help to remove some of that uncertainty, the entire supply chain will benefit. The key to all of this is our integrated approach, not only in how we structure our research, but in the research itself. All our projects are interrelated, with crossovers and flow-throughs of information and discovery. So it's evident that the success of these projects is dependent very much on the strength of our collaborative relationships. that ideal triple helix of government, academia, and industry. Each strand of the helix brings its own perspectives and expertise, and each is essential to develop a holistic view. The strength of our programs lies in our collaborations across this helix, including other government agencies, academic institutions, and our very strong relationships with industry. We have fantastic buy-in from companies for participation in the work we do, donation of samples for research, for our collections, and sharing of data publicly in what is traditionally a secretive industry driven by the perception of competitive advantage. We have some of the brightest minds in the country contributing to solutions for the future of our sector, and it is very true that many brains are better than a few. This is a collaborative program right across that triple helix. We want to ensure that we're asking the right questions, doing the right work to reach the right solutions. Our first step when it comes to critical minerals is to understand what we already have but might have missed or overlooked. For the Hidden Value program, we are taking the approach that what was mined 50 or 100 years ago, or even 5 to 10 years ago, does not match with the unbelievable expansion of demand for a much larger range of commodities. Many new economy minerals are not primary ores, but are found co-located with other more conventional materials, such as cobalt with copper, indium with tin, and so on. Therefore, it stands to reason that a significant component of historical exploration and analysis ignored the full value present in a given deposit. We are building a comprehensive and world-class dataset of critical minerals in known deposits, as well as a reference library of drill core from significant deposits around the state. We're working with the University of Queensland to develop a series of 3D deposit atlases which include all known and public data, as well as donated company data from these significant deposits. One of our flagship projects explores the concept of secondary prospectivity. That is, defining the value of mineral and metal assets left behind in tailings dams and mine waste stockpiles. The example on the left here, Mary Kathleen, is an abandoned site that must be managed and maintained by the Queensland Government at significant cost to the taxpayer, and it's certainly not the only one. There are abundant rare earth and other resources remaining both in the ground and in the Mary K tailings. Recommercialisation of this site would transform it from taxpayer burden to a royalty earner for the state. Reprocessing of tailings would alleviate significant environmental legacy and also satisfy principles of a circular economy. The picture on the right gives an overview of the distribution and size of abandoned mines across Queensland. The potential value remaining in these sites is huge but poorly defined, and yet they remain one of our most promising and easily accessible sources of critical minerals. Our secondary prospectivity project is run through the University of Queensland using the inestimable expertise of Dr. Anita Parbaker-Fox. The project has been running for a little over a year now, and I don't think we even had the results back from the first round of sampling before we had garnered international attention and buy-in from external parties. I will share some of those results in a moment, but it just goes to show that critical mineral endowment in mine waste is ripe for the picking. So here are some of those early results. While we are, of course, looking at a full suite of elements, for now I'm just going to focus on cobalt. The first round of sampling was over a year ago. There has been subsequent sampling, but that hasn't been released yet. The first round included 7 sites, some operating and some abandoned across Queensland. They included a range of copper, copper gold, and copper tin mines. A number of them showed promising cobalt values as shown in this graph. The most enriched by far are the 2 Osborne tailings facilities. Osborne is located south of Cloncurry in the Northwest Minerals Province and is operated by Chinova Resources. Now, whilst Chinova have calculated copper-gold resources on their tailings, cobalt was not included. So this is just the sort of opportunity that GSQ are hoping to highlight from this study. However, one shortfall of this project is that we weren't able to include a thorough drilling campaign on each tailings facility around Queensland. The samples collected in this study are at the surface, or at best, what is accessible using a hand auger. With mounting interest in the project, however, we aim to include drilling in upcoming sampling. This is crucial because we know from historical records that some tailings facilities, for example, Capricorn Copper, received a significant amount of cobalt-rich ore, which is not reflected in the values that you see here. Anita Parbaker-Fox is working not only on an assessment of what is present in tailings dams and stockpiles around Queensland, she is also examining deportment of critical minerals in those samples to understand differences and relationships between the primary ore and the generally weathered and oxidised tailings. She is then developing bespoke processing methodologies for a subset of key sites. This latter has been crucial for buy-in from companies that already know that there is value in their tailings, but are uncertain where to go from there, including potential processing pathways. A second flagship project, also run in collaboration with the University of Queensland, is that of sustainable methods for rare earth processing. I'm going to get on my soapbox just for a moment, but feedback from mineral explorers prior to the commencement of our New Economy Minerals Initiative was that the environmental damage associated with rare earth extraction in other jurisdictions around the world and the associated cost was a strong deterrent to exploration and mining of rare earths in Queensland. Quite simply, there is no exploration without a clear pathway to production. This also includes downstream markets and supply chains. And it is essential for government to recognise that the entire resources to manufacturing ecosystem is integral to stimulating exploration. The truth is that we know we have plenty of rare earths in the ground in Queensland, but the motivation from industry to do anything with those resources is low without government assistance to remove the roadblocks to market. So back to the science. In our Sustainable Extraction project, we examine the application of bioleaching, i.e. bacteria, phytomining, which means plants, and low temperature, low acid hydrometallurgy to rare earth processing. Over the 4 years of the project, we will be testing these techniques on a variety of rare earth ore types available in Queensland. These include the Mary Kathleen type, thought to be a skarn, phosphorites, peralkaline volcanic rocks, IOCGs, laterites, which contain scandium, bauxite red muds, and mineral sands. We have samples for the first 3 as well as a mineral sand thus far. And I am going to talk a little bit about the geology of the phosphorites and the peralkaline volcanics a little later, as they form part of related projects. And of course, of interest on this slide, this image is courtesy of Anthony van der Ent at the University of Queensland and shows rare earth concentrations in fern pinnules as an example of the potential for phytomining. Bioleaching experiments have begun with ore collected from the Mary Kathleen tailings in northwest Queensland. The goal here is to identify the bacteria that contribute to weathering of the rock pile and therefore may be instrumental in releasing rare earths. The photos here show sample sites and sample collection in action, while on the right you can see test tubes containing samples from different locations and different bacterial cultures gathered from the Mary K site. It is too early at this stage to give any results from these experiments. Hopefully, in another 12 months, I can give a more substantial update. Now, as mentioned, the rare earth extraction project also looks at phytomining. That is, using hyperaccumulator plants to harvest specific elements without the need for high temperature acidification and typical hydrometallurgical processes. If you remember the image of lanthanum and cerium in the fern pinnules a few slides ago, the goal of this part of the project is to identify site-specific, i.e. not introduced, plant species for a given area that may act as hyperaccumulators for rare earths. We begin with the top images here, which show high-resolution UAV imagery of the study sites in and around Mary Kathleen. This is the Mary K pit right here. The images are false colour, near infrared to highlight the vegetation. Also shown in the images, but a little bit hard to see, there are some green dots which represent these sample points. On the right, these are the pictures of all of the plant species that were collected from the area. There are various forms of acacia, turpentine, a spinifex grass, and some other shrubs. The Scaevola ovalifolia, or bushy fan flower, contained the highest cerium concentrations, up to 105 ppm. This reflects the relatively high total cerium concentrations in the soil around the mine site. Aerva javanica, which I think is this one here, a desert cotton, was found to be enriched in lanthanum compared to all of the other species. So there does seem to be some rare earth speciation happening within the plants. Now, thus far, I don't think either of these could be called hyperaccumulators. However, early results show the potential for this technique with a variety of other sites and their local plants to be tested. At the very least, we hope that these experiments will show the potential for plants to be used as biomarkers for rare earth exploration in outcrop poor areas, which are common in Australia. We also see the potential use in rare earth mine rehabilitation down the track. So now moving on to the work that we are doing to generate new critical mineral projects and open up new exploration ground to feed the pipeline of the next generation of deposits. Firstly, we're looking at rare earths in a long belt of volcanic rocks containing some peralkaline end members with anomalous to high rare earths. The Peaks Range project, which is here, is an active rare earth exploration project, and the photo on this slide shows the prominent volcanic hills in that area. GSQ geologists are working to expand our understanding of volcanic evolution and composition throughout this belt to better define the rare earth prospectivity of eastern Queensland. We have also spent a lot of time looking at the potential for rare earth mineralisation in Queensland's giant phosphorite deposits. The map on the right shows the location of known phosphorite deposits along the margin of the Georgina Basin, as it flanks the older Mount Isa inlier. A rare earth resource is already defined for the small correlate deposit, here in red, but rare earths have never been investigated for all of these others, some of which are significant in scale, such as this one here is Phosphate Hill Mine. This one, Ardmore, will become a mine shortly, and there are a number of others. I will describe more on this project in just a moment. But lastly, in our new exploration projects, we have a big program of geophysical surveys, which of course are an essential component of pre-competitive data to help companies target their exploration activities. We've designed our upcoming geophysical programs around the areas that we see as currently having the least amount of information, so they're data poor, but the most potential for new critical minerals discoveries. But now back to those phosphorites, as they really are one of our best news stories to come out of last year. And thank goodness we had some good news to share in amongst all the other chaos of 2020. Here is a simple graph showing rare earth concentrations in samples from the Ardmore Phosphorite project in the Georgina Basin. Those are the blue dots. They're compared with other rare earth deposit examples around Australia and in China, which is in red. The Ardmore samples show excellent promise as a source of rare earths. And the good news is that the rare earth concentrations are highest in the most weathered and therefore the least desirable phosphorites from a fertiliser perspective. Therefore, great opportunity exists for synergies within the one operation. There's a lot more that's been done on this project, but our principal geologist, Matthew Valetich, will be publishing all of this soon, so I won't steal his thunder. And that brings me to the end, not of our ongoing work, but at least to what I can share with you today. This has been a snapshot of what we in Queensland are working on in the critical minerals space. We have made some significant achievements thus far, defining the rare earth potential of Queensland's phosphorites, identifying potential green rare earth extraction methods, and garnering international interest in the potential value lying around in mine waste stockpiles and tailings dams. And yet, I feel that we have barely scratched the surface. Our biggest programs are probably the least sexy or exciting, but will prove in the future to be the most useful and most important. That is, compilation of existing data, collection of new reference data sets to better understand relationships between critical minerals and their more traditional hosts. Each of these activities stimulates interest from industry, from investors, from downstream manufacturers. Without a path to market, there is no point exploring. And so in Queensland, we take an entire ecosystem view of the critical minerals industry. Anything less is setting the new economy up to fail. Thank you.